Hello, good day, and I'm going to present you the final project of statistics. In this project, we want to analyze the behavior of different graphics, such as the distribution for discrete variables and distribution for continuous variables. As we study the concept in class, we know that distribution for discrete variables is a countable set of distinct possible values, and when you add all the probabilities, the sum must be 1. Distribution for discrete variables, problem 1. How many classes are you currently taking? As we know, the answer to this question only can be 1 to 5, so the probabilities will be assigned to each number depending on what the student answered. So we got the next table, and as we can see, only the 10% of the students were taking one class, 15 were taking 2 classes, 24 were taking 3 classes, and 22 were taking 4 classes. And 25 were taking 5 classes. This case is a discrete random variable because the students could only respond with a whole number, and the highest value was 5, making the possible answers, as I said before, 1 to 5. With this table, we could do a cumulative probability table. In this row, you will have to add the probabilities of any specific classes and the previous ones. This probability represents the proportion of students taking an amount of classes or fewer. Now we'll continue describing the problem number 2 of discrete variables.
In this second example, we'll see the different behavior that a discrete random variable can have. We are going to analyze the probabilities of the sum of 2 dice, such that as a result we could have from 2 till 12, because we know that we cannot have 1 by adding both dice, so the probabilities will be as shown. In this example, we can see that the probability of getting each number at the beginning is increasing till number 7. Then, from 7 till 12, it starts to decrease the probability. As we know, when we roll 2 dice, we cannot have a 1.2 or a 5.7 or any number with decimal points. The only options of getting a result for this specific case is between 2 and 12. In the first graphic, we can see the specific probability to each case, and in the second, we can see the sum of the probabilities approaching to 1. The 7, that is the number with high probability, is telling us that is the most likely sum that we could get when we throw both dice.
On the other hand, we know that the distribution for continuous variable, you can have an infinite number of outcomes, so we cannot assign probabilities to each specific value. That's why we must evaluate the probability in a range of values. As you can see, this type of graphic is uniform, since any interval of numbers of equal width has an equal probability of being observed. The curve describing the distribution is a rectangle, with a constant height across the interval and 0 height elsewhere. In this case, we know that all the probabilities will lay between 1 and 4. If you want to know the probabilities elsewhere, you'll know that it's going to be 0. In this second graphic, you can see the cumulative probabilities, meaning that is the sum of the probabilities of any value and the probabilities of the lower values. That's why the maximum probability in this case is 1. This type of graphic, as we can see, is an exponential. The distribution of this type of graphic would be as it is shown, where we can see clearly that most of the values are between 0 and 5, and as the x value increases, you have less probabilities of getting that number. So you can say that you'll get a higher probability between 0 and 5 than any other value. Here we can see that it goes from 0 till 1 in y values. As x values increases, we can see that also the probability increases. In this type of graphics, you'll get the probability of obtaining a specific value plus all previous probabilities. That's why at the end, you'll obtain 1. With this example, we can clarify the concepts learned in class, so we can differentiate between a discrete or a continuous value, and how their graphics behave depending on what you are looking for.